All right, we just saw in our last video that if we have our linear equation written in a certain way, then we can automatically pick out the y-intercept and the slope, the two things that we need in order to graph it. That form is called slope-intercept form. If we can get it to look like y equals mx plus b, the m, the number in front, really represents my slope of the line. And the b helps me find my y-intercept. My y-intercept is at the point 0, comma b. And so as long as I have those two things, I should always be able to graph a line. So let's look at a few examples. In example number 3, it says find the slope and the y-intercept of the line whose equation is, and then it gives us a couple different equations. Now, if you remember from the last video, we had to do a lot of work in order to find the slope and the y-intercept. Not anymore. As long as we can get our equation to look like slope-intercept form, y equals mx plus b, I should be able to quickly point out the slope and the y-intercept. So let's do that instead. If you look at example number 3a, y equals 4 minus 3x. Now, the y is by itself, but the right side doesn't quite look like mx plus b. It's a little bit out of order. Let's go ahead and rewrite it in a different order so that the mx goes first and the b goes last so that I can more easily pick out the slope and the y-intercept. So I'm going to go ahead and put the negative 3x first and the positive 4 last. So now my equation looks like y equals negative 3x plus 4. You notice that this is now in slope-intercept form. I can quickly pick out my slope and I can quickly pick out my y-intercept. So now I know that the slope of this line is negative 3, or negative 3 over 1 if you'd like, and the y-intercept, b, is the point 0, comma 4. As long as I have those two things, I should be able to quickly graph it. Let me show you real quick. If the y-intercept is the point 0, comma 4, I can go up 4 on the y-axis, make a dot. If I know that the slope is negative 3 or negative 3 over 1, that's my rise and my run. Negative 3 means I'm going to go down 3, 1, 2, 3, and I'm going to go positive 1. I'm going to do that again. 1, 2, 3 over 1. And look, here is the, whoa, maybe I should rewrite that a little bit straighter. Okay, not great, but you get the point, right? So there's the equation of that line. There's the graph of the line y equals negative 3x plus 4. Pretty quick, huh? Not very much work that we have to do in order to be able to graph it. As long as I can put it in slope-intercept form, I should be able to graph the y-intercept pretty quickly and the slope. All right, let's do another one. This one we might have to do a little bit more work because look at example number 3b. It doesn't look like a y equals yet. And so what we have to do is we have to algebraically manipulate this equation to get it to look like slope-intercept form, y equals mx plus b. So if I'm trying to solve for y and get y by itself, you notice that we need to get rid of the 7 and the negative 3x. Remember when we were solving, we want to get rid of the term that's farthest away. So let's go ahead and add 3x to both sides. The negative 3x and positive 3x zero each other out. So I'm left with a 7y equal to, and if I want to put it in y equals mx plus b, I want to put the 3x first and the positive 27 last. Those are not like terms, so be careful not to combine those. Now, y is not by itself yet. There's a 7 that's right next to it, remember, which means multiply. So in order to get rid of the 7, let's go ahead and divide every single term by 7 to keep my equation balanced. When I do that, I end up with an equation y equals 3/7 x plus 3. Now that it's in y equals mx plus b, slope-intercept form, could you figure out what the slope is? And could you tell me what the y-intercept is? All right, looks like the slope is 3 over 7 and the y-intercept is 0, comma 3. I can plot the y-intercept and then I can use my slope to find other dots, other ordered pairs on that line and then connect the dots and I can graph it pretty easily. Why don't you try one? Try finding me the slope and the y-intercept of the equation negative 3y plus 5x equals 7. Pause the video, see if you can get it to be in slope-intercept form so you can quickly pick out the slope and the y-intercept. All right, did you subtract 5x to both sides? That left us with a negative 3y equal to negative 5x plus 7. Then did you divide every single term by negative 3? Once we do that, we end up with the equation y equals, you see those two negatives make me a positive 5/3 x, minus 7/3, or you could say plus a negative 7/3. So that means my slope is 5/3 and my y-intercept is 0, negative 7/3. That one might be a little bit harder to graph because we'll be estimating where our ordered pairs are, but that's okay. We can still graph it. We can find the y-intercept, and then we can use our slope, up 5, right 3, and graph the rest of my ordered pairs. All right, so this kind of video, this process is one of the most important processes when graphing linear equations. It's really important that we can get our equations in slope-intercept form so we can pick out those two important pieces so that we can graph any linear equation.